Welcome again. In this tutorial, I'll be showing you how the algorithm works. So, given this particular math problem, 22 times 2 plus 10 divided by 2 minus 5 times 4 equal to 29. So the first step is to first of all push them into your ACC in. In the next tutorial, that's the last tutorial, you see how I actually did this. I was able to push all of them: 22, multiplication 2, addition 10, division 2, subtraction 5, multiplication and 4. How I push them into the ACC in. That is first of all where to store them. So, and you have to do them using the binary form. So first of all, remember this is the external circuit, but I'll actually do this practical in the next tutorial. So what you actually do is you input all the figures here in this memory data in, then your clock should be ticking, that is continuously ticking. Let me show example. That is, your clock is ticking, then you have to have your push turned on. Then you can be inputting all the data you have, 22 of them in binary form. So these are the binary formats. You have to start, first of all, you start from the list, because at the end of the day, remember, is last in first out. The first thing you want to do is to solve the first figures here. That is probably 22 times 2 or whatever is the first initial. So you have to start from left to right. So if you're putting them in, you have to put them in from right to the left, so that 22 should be the last thing you will put, so that when you are popping them out, 22 will be the first thing to be popped out. So you are going to start from down here till you get to 22. So when you are pushing them in initially, you start from return till you get to 22 will be the last thing to be pushed in. So instead of starting from 4 to 22, I actually said from here return. So what this return does here is, at the end of the computation, the stack will be empty, and you'll be able to use return. Means this is return here, a sign that is 0. It doesn't do anything in the LEO. It just returns back whatever you have there, and it stands for 0. Your ZO represent, let me elaborate more. This is 0, this represents 1, this represents 2, 3, 4, 5, 6. That is, addition is 6, subtraction is 7, multiplication is 8, division is 10. Why do you need this? Because these are the binary representation of those signs. Like here, multiplication, I told you, is 8, division is 10. Division is 10. My addition is 6. What again? Subtraction is 7, and so on. And another spectacular thing, remember I told you that you differentiate between an operator and a figure with the MSB. So for a number, the MSB is always 0. For an operator, the MSB is always 1. They are not actually used during computation, and that is why in the LU, after computing the LU, what you get is always a figure. So I always make the MSB 0 compulsory, irrespective of whatever you get. So, and you can find out here, when I'm inputting them in, I always keep the MSB. I don't use them in the computation. They actually stand as the major differentiating factor between a sign and a figure. So you can see that all the MSB of all the figures are 0, and you can see that all of them are 0, and all the MSB of all the signs are actually 1. You can see that 1, addition is 1. So that is the difference between a multiplication and 8, is that a multiplication represents 8, but the MSB is 1. But whereas 8 as a figure means 8, and the MSB will be 0. So that is it. So you have to first of all push all of them in. starting from down here till you could get to up. And when you are starting from here to here, you don't start immediately with 4. You have to start with this, with the return, so that you'll be able to get a final output at the end. This is the return 0 0. At the end of the computation, it will return your answer, because that will be the last. This will be the first, because if you push them in from down to up, and when you are popping them out, you start popping them all from up to down. So the first thing you pop is 22. The last thing will be to return your answer. So then again, so I won't be reading them out. Please go through the website so you can go through them, but I'll just briefly explain them using this MS Word. So first of all, the algorithm, I wrote them down on the website. So but to explain them using this MS Word, now this is how it works. This is a math here, and you've already pushed them in. So now it's time to pop them and solve them. So first of all, pushing 22 times 2 and plus this from the algorithm, the first thing you have to do is to push the first 4 items that you've stored. So that means you will push 22 and 2 will be pushed into stack A. Multiplication and addition will be pushed into stack B. So that is your first step. So after that, you compare multiplication and addition, check which of them have higher priority. Since the first one, which is multiplication, has higher priority because multiplication is 8 and addition is 6. 8 is higher than 6, so you do this first one first, the one with the higher priority. If it comes first, you solve it first. So you're going to get 44. So at the end of the day, this whole thing will return back to be this. I don't know if I'm making sense. That is, after solving this will be first solved. So you now get this. Then remember, you've popped only here, just as this is the first pop, and this is the final representation, because after popping them, you now take them to the ALU and multiply them 22 times, so we give you 44. Then the next step is to push in 10 and division. The first push, we push 4, but consequent push will be pushing in 2 at a time. So the next step, we push 10 and division. Then you now compare addition and division, which one has higher priority. Since division has higher priority and is the last, not the first, you won't solve. You have to push in again. You push in 2 and minus. Then you ignore plus. You always compare the last 2 signs. Then we will compare division and subtraction. Since division comes first and it has higher priority because it represents 10, and subtraction represents 7 or so. So since the first one has higher priority, you solve for it. So you take 10 divided by 2 to the ALU, you get 5. So you now get this particular part. Let me repeat again. So this will be what you'll be having. Then you now solve it again. You compare plus and minus, check which one has higher priority. I personally gave subtraction higher priority because I made it 8 and I made subtraction 7 and made addition 6. So since the last one has a higher priority, you won't do anything. You push in the next 2 again, 5 and multiplication. Then you ignore plus again. You check minus and multiplication, which one has higher priority. Multiplication has higher priority because it represents 8 and subtraction represents 7. So you won't solve it again. You push in the next 2. Then you now push 4 and return. So there's a return here. Then you have to ignore plus and minus. You only check for multiplication and return. So multiplication and return, remember return is 0, so it has the least priority. It's the last to be solved. So you now, since multiplication has higher priority, you now take 5 times 4 to the ALU, solve it, then you now get this 44 plus 5 minus, you've already solved 5 times 4, so you now get 20. Remember there's a return here, the return is still here, so you ignore plus, you always check for the last two operators. So you now check subtraction and return. Subtraction has higher priority and it appears first, so you now take 5 and minus 20 to the ALU, you solve it, so this will give you 44 minus 15. There's a return here, remember, so you bring down 44, you've already solved 5 minus 20 to get 15. So you now check my subtraction and return, which one has higher priority. Subtraction has higher priority, so you now take 44 minus 15 to the ALU, you now get 29 and return. So this return will just return back your 29 as your answer, so 29 is the final answer. So this is how the algorithm works. In case if my audio didn't explain it well, I have a very long write-up on my website from step 1 to step 10, which explained it further. So with this, and when you go through the Velo code, and then with my explanation on here, I will do the practical in the next tutorial. Then all these things together, with all of them together, I hope you'll be able to understand how this my simple algorithm works. Thank you so much, and please subscribe to my channel. Thank you.